AI coding agents aren't magic. Strip the demo away and you find the same three parts every single time: a model, a system prompt, and a set of tools wired into one loop. Once you can see that loop, every jaw-dropping demo and every damn failure stops being mysterious. So here's the claim I'm going to prove. An agent is not a smarter model. It's the same model from your chat window dropped inside a loop and handed tools. By the end, you hold three things: the parts every agent is built from, the four-step loop it runs over and over, and the real reasons it fails. The agent is the loop, not the model. Hold onto that word loop because it's the whole video. Start with what's in the box. There are exactly three pieces. Part 1 is the model, Claude or GPT or whatever you point it at. The model does one thing: it reads text and predicts the next text. That's it. It can't open files, it can't run code, it can't see your repo. On its own, it's a very well-read intern locked in a room with no hands. Part 2 is the system prompt. Before you type a single word, the agent feeds the model a hidden block of instructions. You are a coding assistant. Here are your rules, here are the tools you can use, here's how to call them. That system prompt is the agent's personality and its rulebook, and it's just text glued to the front of every request. Part 3 is the tools. A tool sounds fancy and isn't. It's a function the agent is allowed to call, described to the model as a name, a one-line description, and a JSON schema of arguments. Read file, edit file, run command. The model can't run any of them. It can only ask by emitting a structured request. Something has to actually execute that request, and that something is the loop. Here's the engine. The agent runs 4 steps in a circle until the job is done. Perceive,
plan,
act, observe, then around again. Perceive, the model reads everything in front of it. Your request the system prompts every file it's seen so far, the result of its last action. Plan, it predicts the next step in plain language, something like, I should read the test file to see what's failing. Act, instead of just talking, it emits a tool call, read file with a path. Observe, the loop actually runs that tool, takes the result, the file's contents, and pastes it straight back into the model's context. Then it loops. Perceive again now with new information. That's the entire trick. The model never leaves the loop. It can't. Each turn, it either calls a tool or says, I'm done. If it calls a tool, the harness runs it, feeds the result back, and asks the model what's next. Read the test, run it, watch it fail, edit the file, run it again, watch it pass, stop 10, 20, 50 times in a row, and that repetition is what looks like intelligence. It's a for loop with a language model as the body. Let me make the tool call concrete, because this is where people imagine magic that isn't there. When the model decides to act, it doesn't run anything. It outputs a small chunk of structured JSON, the name of a tool and the arguments. Tool, edit file, path auth.py. Old, this block. New, that block. That's the whole action. Just text shaped like a function call. The harness, the actual agent program, passes that JSON and runs the real function. It opens auth.py on your disk and applies the edit. The change shows up as a red-green diff, lines removed, lines added. Then it captures whatever happened, success or an error, and writes that result back into the context. Running code works the same way. The model emits run command per test. The harness shells out, runs your test for real, captures the output, 3 passed, 1 failed. Here's the trace back and hands that text back to the model. The model never touched your shell. It asked, the loop obeyed, the loop reported back, read, edit, run. Every impressive capability is one of these. A request in JSON, a real function behind it. The result fed back as plain text. Now the limit that explains half of all agent weirdness, the context window. The model can only see a fixed amount of text at once, measured in tokens, roughly 3/4 of a word each. A big window today is around 200,000 tokens. Sounds enormous. It isn't. Every turn of the loop starts more in the system prompt, your request, every file it read, every command output, every diff, a few large files and a long test log, and you are burning through that budget fast. When it fills up, something has to give. Older messages get summarized or dropped, and that's called compaction. Here's the catch. The thing it drops might be the exact detail it needed. A function signature from a file it read 20 steps ago is gone, so it confidently calls that function wrong. The context window is the agent's entire short-term memory. It has no other. It doesn't remember your code base between runs. Every session it starts blind and rebuilds its picture one tool call at a time. Inside that fixed budget, understand the window and you understand why long tasks slowly get dumber the longer they run. So where does it really break? Three places and none of them are the model isn't smart enough. First, bad context. The agent is only as good as what's in its window. If it never read the file that matters, it's guessing. And a model guessing sounds exactly as confident as a model that knows. Most hallucinated code is really just missing context. Second, the loop runs away. It edits a file, the test fails, it edits again, fails again, and it starts thrashing, undoing its own fixes, chasing the wrong error, burning 22 calls on a one-line bug. No human pauses to say, step back. The loop just keeps going. Third, compaction eats the plan. On a long task, the early reasoning, the why behind the decision, gets summarized away, and the agent contradicts something it figured out 10 minutes earlier. It's not lying. It genuinely can't see it anymore. None of these are mystical. They are modeled with limited memory, no instinct for when to stop, and total confidence either way. The fix is always the same shape. Give it the right context, keep tasks small, and check its work. So here's the whole machine in one picture. An agent is a model, a system prompt, and a set of tools run in a loop. Perceive, plan, act, observe, repeat. The model only ever predicts text and asks for tools. The loop runs them and feeds the results back. Its memory is one fixed context window, and that window is why it forgets, guesses, and thrashes. The agent is the loop, not the model. And once you see that, you stop being impressed by the demos and start being useful with the tool. Use it that way, small, well-scoped tasks, the right files in context, and you reading every diff. Skip the dream of build my whole app while I sleep, because that's exactly where the loop runs away, unwatched. So one question, and take a side in the comments. Would you let an agent commit straight to main, or is review everything the only sane mode? I read every reply, and the disagreements make the best next videos. If this made the loop finally click, hit like and subscribe. It's genuinely what tells me to keep making these. Next up, I'm pointing a real agent at a real feature and putting the entire diff on screen. Every line it nailed and every line it broke. Subscribe so you catch it. I'm Sensei. Go watch the loop.